Bismillahirrahmanirrahim. Hello everybody, this is an exercise from an exam file, an exam mathematics, National High School of Mathematics, Algiers. This exercise said, let f be a function from 0 plus infinity to 0 plus infinity, be a continuous function. We suppose that the limit of f of x on x when x goes to plus infinity equals to k, which is greater than 1, and the limit of f of x when x goes to 0 plus is equal to l, which is less than 1. Prove that f of x equal x has a solution this equation. Let us start by saying that there exists epsilon greater than 0, such that what? Such that k minus epsilon still greater than 1. And for the same epsilon, 1 remains greater than L plus epsilon. It is sufficient to take epsilon, for example, equal the minimum between we have k greater than 1, so k minus 1 over 4, 5, 6, and so on, and 1 minus L over 4. You can check, it is very easy. This is 1. So for this epsilon, this is true. The limit of f of x over x when x goes to 0 plus equal to L. This is equivalent to, for all epsilon greater than 0, there exists A greater than 0, delta A greater than 0, such that for all x which verifies in the domain of definition and verifies x minus 0 less than A or equal, this implies that f of x over x minus L less than or equal to epsilon. F of x, absolute value of f of x minus L less than or equal to epsilon. This means that f of x over x less than L plus epsilon and greater than or equal L minus epsilon. This is 1. We use the same thing. So here we use the same thing. The limit of f of x over x when x goes to plus infinity equal to, this is to 0 equal to L plus equal to k. This is equivalent to say for all epsilon greater than or greater than 0, there exists, here we use A, we use B, there exists B which is positive, so that for all x which verify x in 0 plus infinity and verify x greater than or equal to B, this implies that f of x over x minus k, this is less than or equal to epsilon. Yeah. We translate this inequality to be f of x over x less than k plus epsilon and greater than or equal to what? To k minus epsilon. So we have these two formulas. The first one is true for all x such that the absolute value of the absolute value of x less than or equal to a, and since x is positive, so it became such that x less than or equal a. And the second, because we are dealing with x from 0 to plus infinity, and for the second one, the limit of f of x on over x when x goes to plus infinity is equal to a. So this inequality, double inequality, is true for all x which are greater than or equal to b. Let us take both of them. If we will take both of them, we will take this one when x goes to 0. We take this side, and for when x goes to plus infinity, we will take this side. So what we are here. We have f of x is less than or equal L plus epsilon times x for all x such that x is less than or equal to L. And we have f of x, is greater than or equal to k minus epsilon times x for all x such that x is greater than or equal to b. Let us, since these double inequalities, both of them are true for all epsilon, if we take epsilon, the minimum between these two real numbers, then we will find a and b such that they are related to this special epsilon. And why we are able to do this? Because these two formulas are true for all epsilon, especially if we choose epsilon equal to this value, we will find a and b. So let us here consider a function f which starts from 0 plus infinity to 0 plus infinity, such that for x we associate phi of x, which is equal to f of x minus x. So what we take phi of a. This means that we take this a. This is equal to f of a minus a, and this is equal f of a. I mean, this is less than or equal. Why? Because f of x is less than or equal to this, so this is less than or equal L plus epsilon a minus a, which is equal to L plus epsilon minus 1 times a. A is positive. But what were here, we said that we take epsilon such that what? Such that k minus 1 still greater than 1, and this minus epsilon still greater than 1, and 1 still greater than L plus epsilon. I mean, 1 is greater than L plus epsilon. This means that this is less than epsilon. The same formula will gives us phi of b. This is equal to f of b minus b. but f of b is greater than k, so this is greater than epsilon b minus b, which is k minus epsilon minus 1 times b. B is positive, and k minus epsilon is greater than 1. This means that this is greater than 0. We have a continuous function such that phi of a is negative and phi of b is positive. This means that there exists some constant c, some c which belongs to a, b, such that what? Such that phi of c equal 0, equivalent to say that f of c equal to c. This means that this equation has at least a solution between a and b. A and b, both of them are related to the epsilon, which is the minimum between k minus epsilon over 4 and 1 minus L over 4. Thank you very much for watching. See you next time.